So now it's time that we begin talking about IP address. Now what is an IP address? So IP address is nothing but Internet Protocol address. So IP over here stands for Internet Protocol. Now understand this. What is an internet? Okay, let's first talk about this first thing, which is internet. So what is an internet? So internet is nothing but a giant network of networks, right? So it is a huge network which internally has multiple networks within it. So this is one network, this will be second network, this will be third network, this will be fourth network. And within this network, there will be machines who will be interacting with each other, right? So there will be machines over here like this, okay? Here also there will be machines, okay? So this outer part is the internet. This inner parts are the networks, and within these networks, you have multiple machines. And when I say machines meaning it could be a smartphone, it could be a laptop, it could be a computer, okay? So it would have machines that can communicate with each other within the network. For example, your home Wi-Fi is a small network within your home. Your office Wi-Fi is a network within your office, and everyone connects to it and communicates to the internet, okay? So that is how it works. So this is what internet is. And then you have protocol. Now, protocol is nothing but a set of rules that defines how data is transmitted, addressed, formatted, and routed between all the devices within the network. So that is what Internet Protocol means. So IP means Internet Protocol. Internet is nothing but a giant network of networks, and protocol means, or protocol defines, or it's a set of rules that defines how data is transmitted, formatted, addressed, transferred, routed between multiple devices within a particular network. Now, we are talking about communication over here, if you notice, okay? So the devices within the network are communicating. So let's say there is one device over here, okay? Let's call it something. So I'll just get rid of this. Let's call it device A. And then you have a device B over here, okay? So A is communicating with B. Now for A to communicate with some other device or any other device in the network, it should know its address. And address will define how one device reaches out to another device within a network. And it would want to reach out and connect with another device and communicate to transfer data or share something, right? You can think of this like you living in a city and you receive physical mails or physical parcels over here that are delivered by a postman. So for someone to deliver a parcel or some sort of an envelope to your place, he will need your address as to how he can reach out to you and send you something, right? Same goes for emails. If someone wishes to communicate with you or email you or WhatsApp you or whatever, so he is going to need your address or a way in which he can communicate with you. Similarly, here, when you have two devices and if they want to communicate, they are going to need each other's address. And this address is known as IP address. So, Internet Protocol address. And without IP address, the internet wouldn't know who is sending and who should receive it, okay? And it makes sure that whenever you are willing to access something or see some data or send some data, it is actually sent to the right device and not to someone else. Without IP address, this data would be lost. Now, when we talk about IP addresses, there are two kinds of IP addresses. So the first is IPv4. Okay, this is one type, and then we have another type which is IPv6. So I'll say IPv6. Now, what is the difference between two? Okay, so IPv4 is the old system of addresses. Okay, and if I have to give you an example of IPv4 address, okay, I would type in over here 192.168.1.1. So this is a simple example of an IPv4 address. Okay, so this is what it is. So it is 4 numbers separated by dots. And this kind of system gives, with this kind of system, IPv4, it's possible to have around 4 billion unique addresses. Now understand one thing about IP address, these IP addresses have to be unique, right? So for one device to communicate with the other device should have a unique address so that this device can talk to only that one and not someone else, right? So IP address has to be unique for every device. Okay, and with IPv4 system or with IPv4, which is Internet Protocol version 4, it's possible to get around 4 billion unique addresses. So when I say billion, it's billion for B. Okay, so yeah, this is huge. But today, today the population has increased so much. There are so many devices that are connected to the internet. Like one person will have 3-4 devices, iPad, he'll have a tablet, he'll have a smartphone, he'll have laptop or a physical desktop or multiple devices. So he's going to have multiple devices that are going to be connected to the internet or to any network, and those are going to need unique IP addresses, and hence soon everybody realized that IPv4 might not be sufficient, and hence IPv6 was brought in. Now IPv6, with IPv6 you can have much longer addresses compared to IPv4. So here this is an example of an IP address in IPv6 format. Okay, so you can say it's much more longer, and with this this number is big, and with this format it's possible to have a lot of IP addresses, okay, which can basically fulfill all the requirements. Okay, so this is a new system, IPv6, and IPv4 is the old system. Now if I have to talk about today a lot of them are on IPv4 only, but slowly they are migrating to IPv6. Now this is the categorization of IP addresses based on the length and the format, but there is one more categorization based on I would say the visibility. Okay, so there is a concept, like one more concept. So let me just duplicate this. Okay, so there is one more concept of public and private IPs. Okay, so there is public and there is private. Now, as the name says, public IP means public and private IP means private, right? The name only says this is public IP and the private IP. So what does public IP mean? Public IP means it's global, it's visible to the internet, and everyone can see this IP address. Okay, so basically this IP address is assigned, this public IP is assigned by internet service provider, which is your ISP, and it is going to be unique across the whole internet. And private IP address is private, and it is supposed to be used within the private network, like your home or office network. You might set up a private network, so it's used over there and it is not visible to the internet, and it works locally. So this is about private and public IP. Now let us come to AWS. Okay, so here we spoke about IP address, public, private, IPv4 and IPv6. So how does all this, how do all these concepts relate to that of AWS? Okay, so let me come to that. So AWS has the concept of private IP. Okay, it has the concept of public IP, and it has the concept of something called as elastic IP. Okay, so let us talk about each one of them. So what is a private IP over here in AWS? So in AWS, private IP is a IP that is allocated to every instance that you create inside the AWS. Okay, it automatically gets a private IP, and of course, like I said, the private IP is used for communication inside AWS only, right? And it cannot be used to connect directly from the internet. Okay, so it's private, and that is why it's called private. And when we say public IP, so if you want an EC2 instance to be reachable from the internet, then you assign it a public IP. Okay, and you can also assign it an elastic IP, which I'll come to, but you can assign an EC2 instance that you've created, provided you want it to be reachable from the internet, you can assign it a public IP. And this public IP is going to map to the private IP of your EC2 instance. Okay, and then you have elastic IP. So what is elastic IP? Elastic IP is nothing but a static IP that does not change even if you restart the EC2 instance. So other IP addresses will change, okay, but elastic IP address won't change if you restart your EC2 instance. So if you have any sort of requirement wherein you want the IP address of the EC2 instance to be static, then you can make use of elastic IP address. Okay, so I hope this is making sense. So all these concepts are there in AWS, and for understanding these concepts, it was important that you understand the entire concept of IP address. So let us talk a bit more about networking and understand a few concepts. So there are a few concepts that we'll talk about. So first concept that we are going to discuss is the concept of VPC. Now, what is a VPC? So VPC stands for Virtual Private Cloud. Okay. Now, what is a virtual private cloud? So let me explain this. So let's say you have a commercial premise. Okay, commercial, residential, or whatever sort of premise. For the sake of example, I'm going to talk about a commercial premise like a commercial office. Okay, now within a commercial office, can you directly enter and can you visit any department by your wish? No, there will be security checks, of course, and once you enter the commercial premise, you should have an ID card. If you don't have an ID card, so your ID card will be checked. Right? And if you don't have an ID card, you will be assigned a temporary ID card or something depending on the protocol or the rules of the premise. And then you will have access to limited area. So for example, you can access the lobby, the common area, the reception, and you can get your work done for whatever purpose you have visited the office. If you are an employee, you can of course visit directly just with the ID card and you can get inside the workspace. Okay. But even after you are an employee, you cannot access departments like finance department or the server room. You cannot access that because accessing those sort of rooms or those sort of sections within the commercial premise requires special access. You cannot directly go and enter the finance department. You would want the access for finance department. You will need the access for server room if you wish to visit the server room. Right, so these all things come into play when we talk about commercial premise. Now, when we talk about AWS, okay, on AWS you have multiple servers, you will have multiple instances running. So this is one instance. Okay, let's say this is instance 1. Okay, so there could be multiple instances, multiple servers, a lot of things that could be going on within an AWS account or on AWS. Right, now there has to be some boundaries with which this is protected. So that is where this concept of virtual private cloud comes into a play, right? So VPC is like it's like your own private area inside the cloud. Okay. Now in cloud, there could be multiple instances, right? You have this instance, you have that instance. Okay. So if you want to segregate these two instances from the rest, okay, what you can do is you can set up a VPC. And then you can have these two instances within that particular VPC. So this area is nothing but a virtual private cloud. So this is VPC 1, for example. You can name your virtual private cloud or VPC over here. You can create VPC 2 over here. Okay. And you can add some instances or some resources over there. Okay. So within a particular VPC, you control everything. Okay. And you can think of you're setting up a private thing or a private area within AWS cloud. Now, few things that I would want to tell you about VPC is, so one person will have one account on AWS, and within one account, you can have multiple VPCs created. So this is VPC 1, this is VPC 2. Okay. So you can have multiple VPCs created within one account and they will be completely isolated from each other. They will be treated like two separate networks, but within a single AWS account. Okay. At the end of the day, what is VPC? So VPC is nothing but a separate network that you are setting up, right? It's a separate area, separate network, and you will have resources within that particular network. For example, here I'm showing instances, right? So within one account, you can have multiple VPCs set up, and these two networks could be completely isolated from each other. Okay. Also, if there are two accounts, so of course this goes without saying, if there are multiple people with two separate accounts, they are creating VPCs in their own respective account, they also will be isolated from each other. Okay. So that is something that I would want you all to understand. Now, when you create a VPC on AWS, okay, you will have to specify the range of IPs that you want to be associated within the VPC. So for example, here I'll mention range of IPs. Okay. So when you create VPC, you will have to mention the range of IPs that you want to be associated within that particular VPC. Okay, and this is something that you will have to enter on the dashboard. So now we are clear with the concept of VPC. Now let's talk a bit more. Now when it comes to VPCs, when it comes to networking I should say, when it comes to networking within AWS, there are quite a few concepts that come into play. Okay, so first one is VPC that we spoke about. We have concept of subnets. We have concept of route tables. We have concept of network gateways. okay, or I should say NAT over here. Okay, and we have concept of security. Okay, so let us talk about each one of them. So what are subnets first of all? Okay, so I'm just going to have or we can have two VPCs over here. Okay, so I'll just move this towards this side. Okay, I'll make this one a little bit bigger. Okay, now what are subnets? So VPCs can be divided into smaller segments. So let's say this complete thing is a VPC over here. You have multiple resources within the VPC. Now what you can do is you can create multiple areas within VPC itself. Okay, for example, if you think of commercial premise, okay, you have commercial premise over here. Within commercial premise, you will have multiple departments, multiple areas, right? This is the lobby, this is the reception area, this is the finance department, right? Similar way, you might want to have segregation, some sort of segregation within VPC itself. And this segregation or dividing VPC into smaller segments is known as subnet. So this is a subnet, and then you can have one more subnet over here. This is another subnet. Okay. Now subnets are also of two types. So this one is private subnet, another one is public subnet. Now within private subnet, you can have resources. So let's say we have an instance over here. So let's say this is one instance within this subnet, and this particular subnet is so this particular subnet over here is private. Okay, let's say this is a private subnet like so. Okay, so if this is a private subnet, what will happen is whatever resources are there within this particular subnet cannot directly communicate with the internet. Okay, so coming again over here. Okay, so this is a private subnet over here. So first of all, VPC can be divided into smaller segments, I said, and those segments are called as subnets, right? Now subnets are of two types. One is private, another one is public. Now, a private subnet is a kind of subnet whose instances cannot directly communicate with the internet. So, for example, if you have a private subnet, and let's say if this is running an EC2 instance over here, okay, then this instance cannot communicate directly with the internet because, of course, it goes by the name itself. Okay, this is private, right? So, it won't communicate, it won't be allowed to communicate with the instance because this is a private subnet, right? And then you have another thing which is a public subnet over here, right? So this is public subnet. So public subnet is a subnet whose instances can directly communicate with the internet, and they will do it via internet gateway, which I'll be coming to. Okay, but for now, just understand public subnet is public. Everything, all the instances, all the EC2 instances that you will be running within public subnet can communicate to the external world, but within private subnet, this is not allowed. Okay. Now there will be IP addresses that will be assigned. Okay, so whatever instances are being created within the subnet. So let's say you create an EC2 instance over here in the public subnet. So it will have a private IP as well as a public IP, right? Public IP is optional, but private IP can be used. It is private, right? And it can be used within VPC or between the instances. And the public IP that it would have allows the instances to communicate with the internet. Okay, so that is what the IP address is, or how the IP address works and how the assignment works. So private and public both are the kind of IPs that you will be seeing on the dashboard when you create EC2 instances. Okay, so this is about subnet. So just reiterating, what is subnet? So whenever you divide VPC into smaller segments, it is known as subnet. Subnet are of two types. One is public and other one is private. So this is clear. Now let us talk about route tables, NAT. Okay, so first we'll talk about route tables. Okay, what are route tables? Before talking about, or first we'll talk about NAT gateway. Okay, not route tables. So I'll just reduce the size of this a bit. I'll just get rid of this from here. Okay, and I'll move this to the top, and I'll just increase the size of this. Okay. Now what is a NAT gateway? Okay, so NAT gateway allows the instances in the public subnet, private subnet to communicate or interact with the internet, or to access the internet is what I should say. That is what NAT gateway is. So along with NAT gateway, there is also something called as internet gateway, which I just forgot. Okay, internet gateway over here, which I can say IGW. Okay, so these both are gateways. Okay, these two are gateways over here essentially. And with gateway, you decide who communicates with the internet and who does not. Okay, so NAT gateway. So here I'll just create a NAT gateway. Okay, so using a NAT gateway, what happens is private subnet instances will communicate with the internet. Now one question you will have is, hey, you just said that the instances in private subnet are private and they cannot communicate with the internet. Then why would you bring in NAT gateway, and why are you allowing them to connect to the internet? So there are few reasons wherein instances in the private subnet might want to communicate with the internet. Okay, there are few instances, so hang in there. So one instance is, let's say if you want to download some sort of dependency, you want to update the software, you want to install a package within that particular instance, you want to do something, or basically you want to bring something from the internet, like downloading, installing, cloning a Git repository within this instance, right? So in that case, you would need access to the internet. Okay, but you won't want the outside traffic to come to the instance in that case, right? So this NAT gateway allows us to do that. Okay, so NAT gateway allows the instances or resources in the private subnet to initiate outbound connection to the internet, like downloading updates, installing any sort of packages, installing softwares, and it prevents inbound internet connection. Okay, I hope this is making sense. So what is the speciality of NAT? Why is the traffic going through NAT in private subnet? Okay, in private subnet, the speciality of NAT is that it allows the instances within private subnet to communicate with the internet. Okay, and the communication is outbound. So instance 1 can communicate via NAT gateway to the internet. Okay, but someone outside, someone on the internet cannot communicate to instance 1 because the IP and everything is masked behind the scenes. It is masked by NAT gateway. So the outsider world won't know that there is an instance behind the scene. Okay, so this is NAT, and we have internet gateway as well. Okay, now what is internet gateway? So internet gateway is basically a component that allows communication between instances in your VPC or within the subnet with the internet. So if there is any instance in the public subnet that wishes to communicate with the internet to and fro, then you will make use of internet gateway, IGW. Okay, so over here, this is public, right? So it can communicate with the internet, and outsider can also communicate with this instance. So both way traffic is allowed, and that is what internet gateway is. Okay, so it basically enables, internet gateway basically enables the internet access to an instance in public subnet. Okay, but NAT gateway on the other hand is allowing only outbound traffic to the internet and not inbound. Okay, I hope this is making sense. And why are we doing this? Why do we have NAT? Because you cannot keep an instance completely private. Okay, you will need an instance, like there will be tasks where an instance might need some sort of software, it might need an OS update, something like that. So how are you going to do that? So only outbound traffic is allowed. IP address will be masked when this particular instance communicate with the internet. IP address is hidden via NAT and it is not shared with the outside world, so that it's protected because it's private. Okay, so all those things are taken care by NAT gateway and things are kept private, and outbound traffic is not allowed at all. So outbound is only allowed, inbound is not allowed at all. So that is what these gateways do, and these two gateways serve different purposes. NAT gateway is generally for private subnet and internet gateway is for the public subnet. Okay, so I hope this is making sense. Then let's come to the topic of route tables. Okay, now what is a route table? So route table determines how traffic flows within the VPC to and from the internet. Okay, so if this particular instance wants to communicate to the internet, what it's going to do is it is going to first go to route table. Okay, now in route table over here, so let's say this is a route table. This is the public IP over here. This is the so it will have an entry over here wherein if it wants to communicate with the internet, okay, this is the entry over here. Okay, so this entry is going to be within route table. Okay, so let me create a table sorts over here. Okay, so let's say this is a route table over here. I'll say route table. Okay, let's say this is a route table, and let me bring it over here. Let's say somewhere over here. Okay, so I'm showing it over here. Okay, because of lack of space, but this is completely okay. Or I'll bring it over here. Okay, here. Okay, so what will happen is, okay, now instance 1 wants to communicate to the internet. How is it going to communicate? It does not know, right? So it is going to make use of route table and internet gateway. Now how both are being used? Now route table, first of all, is a component that defines a set of rules. These rules are called as routes. Okay, that is why it's called as route table. It holds all the routes. Now what are routes? Routes are nothing but rules that control where traffic from your subnet or gateway is directed within. So basically, how communication happens within this VPC is what is being defined by route table. Okay, so let's say, for example, over here, this particular instance wants to communicate to the internet, and route table will have the entries in the form of destination and the target. Okay, so this is the destination. Okay, so if the instance 1 wants to communicate with the internet, it is going to come to route table, and there will be this kind of an entry. And what this tells is, if this is what instance 1, or this is what if you're looking for, then you go to the internet gateway. Okay, so from here it will come over here, it will see, okay, this is the entry. So if this is the thing, then I need to talk to the internet gateway. He'll go to the internet gateway, and then from there he'll get the internet access. So it is basically a router in between, which is doing the job of routing the traffic, okay, within the VPC. I hope this is making sense over here. Okay, so what is it having? It is having basically a set of rules, and how the rules are defined, it is defined in the form of destination on the left hand side, and then on the right hand side you have target. Okay, so that is what it defines. Now one question you might have, or people who are not familiar with networking, they might have, is what is this 0.0.0.0, and you are telling me that if the instance 1 wants to communicate to the internet, he's going to look for this 0.0, and he's going to talk to the internet gateway. What is this 0.0? So this 0.0.0, 4 times 0/0, this is not an actual device or an IP. Okay, it is a special notation that means all IP address. Okay, and basically it tells that if it does not match any sort of route, so it's basically a wildcard is what I can say in simple terms. Okay, so it says, okay, so see, if instance 1 wants to communicate with something, it is going to have the IP. Right, let's say if it wants to communicate with some other instance, it is going to have the other instance IP, and there will be an entry in route table which will say, like, this IP, like IP source will go to IP target, something like that. It is going to have this kind of an entry over here, right? So this is the entry that it will have, right? So if it wants to communicate to some other instance, it is going to come over here, it is going to look for that instance IP, and then it is going to communicate. That is how the communication will work. But if it wants to communicate to the internet, it is not going to have any sort of IP. It is going to come over here, okay, and if this is the entry over here, it means internet gateway. So that is how it is going to work. Okay, so any other traffic, this simply means that any other traffic or all traffic that is not destined for VPC itself should go to the internet gateway. That is what this line simply means. Okay, so I'll just remove the second line over here, okay, and I'll add it over here. So this is how route table will function over here, right? And this is a public subnet. Okay, so I'll just extend this a bit. Okay, now here it can be multiple entries. Okay, I've increased the size of this. Okay, but here this is about the example that I gave is for the internet gateway, right? So instance 1 wants to communicate. So how is it going to communicate? It is going to come over here. It is going to look for the route over here. Okay, so something like this. And then this traffic is going to go to the internet gateway, and via there it is going to go to the internet. Now same works in the private subnet as well. So it is going to have a route table over here. Okay, so let me duplicate this. So this is the route table over here. So I just rejigged the diagram and just make it a bit more spacey and clear. Okay, so here I've added route table. Okay, and this is a NAT. Okay, so this is also route, so I should mention over here, this is route table. Okay, now the same thing, the same logic of route table that I explained over here works over here as well. So if instance 1 wants to communicate with the internet, it is first going to look for, it is first going to go to route table, and then from route table it is going to get NAT, and then it is going to talk to the internet. And this is how route table helps in routing traffic within a VPC. So this is about the gateways, which is NAT gateway, internet gateway, and route tables. Okay, now let's talk about security. Now when it comes to security, there is a concept of security groups. Now this is applied at the instance level. Okay, so if you want if you want to regulate some sort of inbound, outbound traffic at the instance level, you can do that with the help of security groups. So yeah, that's about these concepts associated with virtual private cloud. You will hear these terms very often, and that is why it's important that you understand these terms really well and how things function when it comes to networking in AWS. So now is the time that we begin talking about CIDR. Now, what is CIDR? CIDR stands for Classless Inter-Domain Routing. Okay. Now, before I talk about this, I want to clear out few concepts so that when we talk actually about CIDR, you have a better understanding of what CIDR is. So I'm not going to jump directly to this term, because if you're a beginner, this term might seem a little bit confusing, complex to you, right? So what I will do is, first let's talk about a bit about IP address and a structure of IP address. So here I've added a couple of things. Okay, so I've written IP has 32 bits. Okay, so this is an IP address here. This part you see 192.168.1.10. This is an IP address. If you're from a technical background, you might know this is how IP address looks, and numbers keep on changing. Okay, so there are a lot of IP address, and I've taken this example. So IP has 32 bits. Right now, what does 32 bit mean? So 32 bit means that here 192. So every separator over here dot. So there are 4 numbers over here in this IP, right? 192, 168, 1 and 10. Now each number is represented using ones and 0. Why ones and 0? Because that is how computer understand things, right? So if you're talking to computer, that is how things are represented in the computer world, 1 and 0, right? So every number over here that you see in this IP address is represented using 1 and 0 in this form, okay? And every digit over here, like every 1 and 0 is called as a bit. So 192 is being represented by 8 bits over here, right? So 8 plus 8 plus 8 plus 8 is equal to 32 bits, as you can see over here. Okay, so what are we concluding over here? IP address consists of 32 bits. This is important for you to understand. Now, this IP address that we were talking about can be divided into 2 parts. Okay, the bits that exist in this IP address can be divided into 2 parts. One is the network bit and other is the host bit. Okay, before I talk about network and host bit, I would like to mention one more thing over here. Okay, so this representation that I'm showing you over here is of IPv4. Okay, so in IPv4, IP has, okay, I have written IP has, okay, there is a typo. So IP has 32 bits in IPv4. Okay, so just to clear out the confusion over here. Now, this IP has network bits and the host bit. Now, what is a network bit? So, network bit identifies which network a device belongs to, and host bits will identify the device itself within that particular network. Okay, so understand this. Okay, why this is a network. Okay, and there are multiple devices. Okay, there will be multiple devices. Okay, now this is a network, and we should have some sort of notation over here within the IP itself, or device should have some sort of notation wherein it can represent itself as a part of the network. So within IP, what happens is some bits are used to represent the network itself, and some bits are used to represent the host itself. So the network bit will identify which network the device belongs to, and the host bit will make sure it identifies the device itself uniquely on the network. Okay, so for example, if I have to give you an example over here, so here this IP example that we have taken, I'll take the same one. So if you have the IP with this definition, so 1.x, okay, so let's say here first 24 bits are network bits and the rest are host bits. Okay, what this means is this part of the IP address, which is 24 bits, okay, because 8 3s are 24. Here you have this, each number is being represented using 8 bit, right? So this is 24 bit. So first 24 bit or 24 bit within this particular IP is, let's say it's being used to represent the network, okay, and the rest of the part, which is the remaining 8 bit, is being used to identify the host. So if you have the IP over here 192.168.1, so it means that it belongs to this network, okay, and this host will also have the same IP, and this will also have the same IP. Okay, only the host details will change. So for example, I'll just give you an example. So over here, this can be 10. Okay. Now this is also the part of same network. So first 24 bits will be same. Now this will be 11. Okay. And this will be 12. Okay. So X value will change. Nothing else will change. So this is the concept of network and host bits. I hope this is making sense. This is very important for you to understand before we talk about CIDR and how IP ranges are being assigned in VPC and all. Now, once you're clear with these concepts, let us talk about CIDR. Now, CIDR stands for Classless Inter-Domain Routing, and it's a way to specify IP address ranges using compact notation. Okay, so why do we need this sort of notation to specify IP address ranges? Let me explain that. So you create a VPC. Okay, let's say you create a VPC. What is VPC? It's a virtual private network. It is of course going to have multiple devices or instances within it, right? And within a network, so this is a network. Let's say this is VPC itself. Within a network, you will have multiple devices, and each device will have an IP address, right? So which means that this network needs a range of IP address which can be used by devices or resources that exist within this network, right? And for doing that, we need this CIDR notation using which you can represent the IP address ranges that a network will make use of. Okay, so let me be more clear and let me share how CIDR is represented. So I'll paste something over here. Okay, so this is the representation of CIDR. Okay, so let me pull this a little bit up. Okay, we'll take this above, and I'll take this a little bit above over here. Okay, so this is how CIDR is represented. Okay, so here. Okay, this is how CIDR is represented. So you have the first part, which is the IP address, and then you have the prefix length. Okay, and in between you have /. Okay, so this IP address is the base IP address of the network, and the prefix length is the prefix length which is indicating how many bits are being used by the network. Now let me add an example of CIDR over here. So what I will do is, let's say I want to mention a range for a network. So I'll say 192.168.1.10. Okay, so this is the base IP. Okay, base IP address, and then I'll add a /, and I'll say 24. Okay, now this is CIDR. Okay, this is CIDR, and what I'm doing is, this is the base IP and this is the prefix length. Okay, which indicates how many bits are being used for the network representation. Okay, so here if I have to showcase, okay, this would be network bits. Okay, so network bits. So network bits will be 192.168. 168.1 will be network bit over here. Okay, and I'll reduce the size. And then you have, so instead of network, you will have this is host bits. Okay, something like this, and this will be 10. Okay, 10, something like this. So network bits is being represented by 24 bits over here. So this is 24 bit in length, right? Remember this diagram. So every number has 8 bits. So there are 3 numbers. So network representation is being done by 24 bits. That is what you have mentioned over here, 24 bits, right? So this is what is translating over here. And host bits is 10 over here. So it could be 10, 11, 12, and like that it can go on. Okay. And any device that has this IP address, or it starts with this IP address, any device that starts with this IP address is considered as the part of this network over here, which you are representing with this notation. So I'll just replace this with this diagram over here, okay, or this image. Okay, so you can see this over here. Any device with this is considered a part of this network over here. So I would also mention that this part, which is prefix length, which is after the /, this is also sometimes referred to as net mask, which just indicates how many bits are being used for the network portion. Okay, and which is 24 over here. Okay, now I would also want to talk about how you can calculate the number of IPs in a that can exist within a network. Okay, using this representation. Okay, so there is a formula for that. So this is the formula. Okay, so number of IPs is equal to 2 raised to 32 minus prefix length. Okay, so in our case over here, okay, we have 24, which is the prefix length. So 32 minus 24, what will it be? So 2 raised to the power of 8. That is what the output will be, which will mean that 2 raised to the power of 8 is so 2 raised to. So 2 raised to the power of 8 is 256. 254 in my opinion. Yeah. So with this notation or with this CIDR notation, you will get 254 IPs within the network to use. I hope this is making sense. So we are just subtracting the prefix length that we have mentioned over here, and you get whatever number you basically raise that to 2, and you get the output. So I hope everything until now is pretty clear. Okay, this can be a little bit overwhelming for beginners, but I'll just give you a gist again. Okay, so we were talking about CIDR, and to understand CIDR, it's important to understand IP addresses as well. Okay, so I'm talking about IPv4 address, and an IP in IPv4 notation has 32 bits. Okay, and there's an example of an IP address over here. And if converted to binary, you can see over here, each number is represented using 8 bits over here, and which sums up to 32 bits. That's how we got 32 bits. Now, an IP address has 2 parts. This number is used for representation of 2 things. I'm sorry. So this number over here is used for representation of 2 things. One is the network part, another one is the host part. So some parts or some bits in the IP are representing the network, and some are representing the host itself. So here we saw this example of a network. Within network there were multiple devices, and this network, so every device that had this IP over here, which is 192.168.1, was part of this network. So network representation was being done by 24 bits over here, and the host representation was being done by 8 bits, which is the latter part or the last part of the IP. And you can see over here how the host part was unique, but the network part was same for all. Now, one question you might have is, why do we need this network part and host part in an IP address? Why does this exist at the first place? So the answer for this is routing, basically. So when a internet packet or when a data packet or any sort of information travels across the internet, routers use network portion to decide which network should we send this particular thing to, right? And based on this network representation, it decides, okay, this is a network that it belongs to, and then it will come over here, and then within this network, which device should it go to? Okay, so this latter part will be used then, and it will be delivered to that particular device. Okay, and it also helps for organizing the devices, and it's basically more efficient. That is what it's there. Now coming to CIDR, CIDR is basically used to represent over here. So here you can see it is represented using 2 parts: IP address / prefix length. IP address is the base IP address of the network, and prefix length determines how many bits are being used for network representation over here. So I'll just mention representation over here. Okay, so that is what it used for. And here we saw an example over here. So 192.168.1.0/24. So here what it means is this first part is used for network bits, and the later part, which is 8 bits, is being used for the host bits. And any device with this IP address where X is not defined, X can change, okay, based on the device. But if this part is common, then it's considered to be the part of this network. And what happens is, when you define CIDR range, okay, you should also know, or you would want to get an idea of how many IPs can be used within that particular network. Okay, so for example, if you define this as a CIDR range, with this CIDR range, you can have 254 IP addresses, right? So it's 2 raised to 8, and this is a formula. I've deducted the prefix length, and I got 254. Now, I would also want to talk about online tools that are free to use and that illustrate CIDR, subnetting, and network structure, especially for beginners. So I would like to highlight this website over here, which is judis.de/ipcalc. Okay, so it takes an IP address, netmask, and calculates the resulting broadcast and network. It gives you a basically idea of how many IPs are going to be there if you just don't want to calculate it yourself. So let's say I enter the IP address over here as 10.0.0.0. And if I mention the net mask over here as 24, okay, so you can see over here, okay, so this basically, this address that I've mentioned over here is the host address. This is the starting point of the network, okay. Then I have the net mask, which is nothing but the prefix length, okay. So here it is being represented as net mask, okay. So this is the prefix length, and this means that 24 bit are used from the IP address for network representation, leaving 8 bits for the host. Okay, so here if you see, okay, you get something called as address over here. Now what is this address? So this address basically is the, so you can see over here, this is the binary representation of the starting address. Then you have net mask over here. Okay, so this shows which bits are in the network and which bits are network bits essentially and which bits are host bits. So here you have mentioned 24, right? So here, like first 3 numbers over here, first 3 numbers are network bits, and then the rest is the host bit. You can see. So this is represented using network. You can see over here, this is represented using 1. Sorry, not network, but 1. Okay. And then you have wildcard. So wildcard is the inverse of net mask over here, and it is showing which bits are for host over here. So this, all zeros are for network, and then this part is for host over here. Because, you know, out of 24, 8 bits are left. Okay, I hope this is making sense. So this is just inverse of each other, net mask and wildcard, just to give you a clarity which bits are being used for network and for the host. Okay, then you have network over here, and this is the identifier of the subnet. Then you have broadcast. This is a special address that is used to communicate with all the hosts in the network. So that is what has been mentioned over here. Host min over here. So host min and host max over here. So these two things form the range of reusable, or sorry, not reusable. These two form the range of usable IP address. Okay. So within this network, the hosts can have the IP addresses ranging from 10.0.0.1 to 10.0.0.254. So it can start from 10.0.0.1, 2, 3, 4, something like that. Okay, and it just keeps on going. And then you have total 254 IP addresses to use over here. That is what it's showing you. Okay, the total 254 because the net mask is 24. Okay, that is how it represents. I hope this is making sense as to how this calculator works. If you convert this to 16 over here, which means now only 16 IPs or 16 bits will be used out of this for representation of network. So which means you will get more IPs within the network. So if I say calculate, you can see over here, now I get roughly 65.5 thousand IPs within this particular network. So you can see here only 16 bits are being used for representation of network, and the rest 8 are being used for representation of the host, right? So you got more bits within, you got more bits basically for hosts within the network. I hope this is making sense. So the moment you got more bits for representing the host within the network, you can have more devices. Okay, so I hope that is making sense, and that is why you can see over here, host min is 10.0.0.01 and 10.10.255.254, which equates to 65,534 combinations. And these are the number of IPs, unique IPs that you can have within this network if you are creating a network with this CIDR. I hope this is making sense. And by our formula, so this is 16, right? So if you come over here by our formula, let me replicate this. So it will be 2 raised to 32 minus 16, right? So it will be 16, which will be the same number, which was 65534, I guess, right? 65534, yeah. So this will be the number, okay, using our formula. So I hope this online tool also give you some good clarity. These tools are there, they are free to use. Okay, you can make a note of the URL over here. These are free to use, and they help you calculate in real time. Okay, so if you're lazy, you don't want to calculate, and you want to deal with all these calculations, you can make use of this. You get a range and everything, and based on this, you can design your networks. So I hope this helps. Okay, and here I've also added the key points that we have discussed so far. Now, one question you will have is, okay, I know what is CIDR, I know VPC, I know how networks work and how IP ranges can be assigned and how I can mention the IP ranges. But how does it relate or how does it come together on AWS? Okay, so yes, let's start talking about AWS now. Now on AWS, whenever you create a network or whenever you create a VPC, so this is the VPC that I will define. Okay, let's say this is my VPC. Now, whenever you are defining the VPC from the AWS dashboard, you will have to enter the CIDR block. Okay, now CIDR block meaning here you can come to this tool, you can mention the base address and the net mask over here. Okay, and you can calculate and you will have to plan things a bit. Okay, now this tells you that there can be these many host IP addresses within this particular network if you create. Okay, so whether you want to have these many IPs or how you want to structure your network. So based on that, you will define, and what will happen is here, let's say I'll duplicate this and let's say I defined a VPC with the block of 10.0.0/16. Okay, so this is going to result in approximately, so the number was 65,000. Okay, approximately 65,000 hosts within this particular network, right? Or I can get the exact number, 65,534. Okay, so it will be 534. So these many hosts can be there in this particular network. Okay, and then within this VPC, if you create subnets over here, so let's say there is one subnet here, there is another one here. Now here, each subnet can have the unique IP range, okay, within the VPC. So for example, over here, okay, not this one, but here, what I can do is I can replicate this, and here you can have this subnet being represented with this IP, and you can make this as 1, and here you can say 24. Okay, so this can be one subnet, okay. And then you can have another subnet which is similar, but the IP range changes over here. Okay, so this way you are creating two subnets over here. Okay, and you can see over here it's it will have 256 unique or 254 unique IPs within this particular network over here. Okay, so this is something that you can do. Okay, so basically VPC is the large network that you will have over here defined using CIDR. Okay, and you will define the CIDR size. So here, the second prefix, you will have that based on the number of hosts needed. Okay, then you will have small networks inside, which is subnets, and you will make sure that right ranges are assigned to subnets. Now, when you are assigning ranges to subnets, make sure that IPs should not overlap between multiple subnets. That will create problems. So that is something for you to take care of. Okay. Also, I would like to correct one thing, like in one of the explanations I had mentioned over here, usable IPs is equal to 2^32 minus prefix length. Okay. So this -2 was also you have to subtract 2. So 2^8 is 256, but you are subtracting 2 over here. Right. Here also you are subtracting 2. It's otherwise the value is 65534. So this will be 2^8 minus 2 over here, like so. Okay, and this also will be same. So I actually made a mistake over here. Okay, so this is something that I wish to correct, and based on that, you will make use of this. This is how you will like carve out your VPC and design your network based on the knowledge you have got so far. Okay, and you can of course make use of this tool over here. So for example, the subnet that we are creating, we can say 1 over here, and you can add 24 over here. So for subnet also you can do this calculation, and you can see over here, you are getting 24 hosts over here within this particular subnet 1. And if you update this to 2, the number of hosts will be same because the net mask or this particular value over here, prefix is not changing. Okay, I hope this has been useful so far and you have been able to connect everything to AWS, and I hope you have some decent clarity on this. So CIDR is used to define network or IP ranges over here within a particular network. That is what CIDR is used for. And the notation, this is a notation, but if you understand this, it can be overwhelming at first in the beginning. But once you understand this, how you are calculating stuff and all of that, it becomes a cakewalk. Welcome back. So now is the time that we go hands-on with VPC and we set up, create VPC, create subnets. We set up the gateways and see how everything works together. Okay, so what I'm going to do is I'm going to come over here, okay, to AWS. Or first of all, let me give you an overview of what we are going to create. So here you could see this diagram. Okay, this is the diagram that we are going to simulate, and this is the architecture that we are going to build. Okay, so first of all, I'll tell you, like, the outer thing over here is the region, and this is the AWS region. Okay, the region resides, like AWS has different regions, right? North Virginia, Mumbai. You can select the region. Okay, so within a region, we are going to create a VPC. Okay, this is the CIDR range for the VPG. Okay, this is the CIDR, and within this VPC, you are going to have two subnets. One is the public subnet, and other one is the private subnet. And this will be the CIDR for both. Now, within both, we have EC2 instances and the private subnet. So the instances or whatever resources you create within private subnet, of course, it is going to need the internet access to update operating system, install packages and all of that. Okay. So I'm going to enable one-way communication to the internet using the NAT gateway. So you can see EC2 instance in private subnet is communicating via NAT gateway to the internet. So here we are communicating with the internet, right? And this is only outbound communication. So inbound, if someone wants to communicate to the private instance, he won't be able to, because this instance IP address will be masked and it won't be shared with the outside world. So this is only one-way communication that is happening through the NAT gateway. And then we have EC2 instance, which is communicating, or which is residing in the public subnet, and it is communicating using the internet gateway to the outside world. Okay. So this is the entire structure that we are going to simulate, and we are going to understand how we can bring this entire thing to life. So what I'm going to do is I'm going to come over here to the AWS dashboard. First thing first, we are going to select the relevant region that we need. Okay, so I'll select Mumbai over here. Now, once we select the region, what I'm going to do is I'm going to head over to VPC. So VPC is a service, as you can see over here. Okay, so select this VPC. Now your VPC dashboard will look something like this. On the left hand side, you're going to see different stuff like virtual private cloud, your VPCs, your subnets, route tables, internet gateways, and all of these options we have over here. And here you have resources by the region. Okay, so here you can see I already have one VPC. Okay, if you go to your VPC or you click on VPC, you're going to see one VPC already existing over here. Is this the VPC that I have created? No, this is a VPC that you will find in any new AWS account or any account on AWS. Even your account, if it's new, you're going to find this, because this is a pre-created network by AWS covering the entire region. Okay, and you can see over here, this is the CIDR of this particular IP, of this particular VPC. So this is a CIDR. Okay, now it is also going to have the public subnet over here by default created. So here you can see these are the subnets that exist along with some CIDR ranges being assigned. Okay, then you have route tables. You will also see a route table exist, and if you go inside the route table, you're going to see destination and target over here, status active. Okay, you can see this is the destination and this is the target over here, status is active. Okay, and if you go to so you can see the subnet associations over here as well. Okay, where this is being associated, you can see the internet gateways. So you can see one internet gateway being created over here. Okay, and NAT gateways, if you go over here, there are no NAT gateways found. Okay, now if you go to VPC here, if you click on this, you will see something called as resource map, which is going to give you an idea. Or so if you click on this info, it will tell you, it shows the relationship between resources inside of VPC and how traffic flows from subnets to internet gateways, NAT gateways, internet gateways, and gateways endpoints. So basically, it's showing the flow of entire traffic. This is very helpful to understand what is happening inside a particular VPC. Okay, so you can see over here, this is our VPC. Here you can see subnets. These are 3 subnets that exist within this VPC, and there is one route table over here which has 3 subnet associations and 2 routes total. And then here you are seeing internet gateway. So these all are being connected to the internet gateway. Okay, you can see the CIDRs over here. Okay, and flow logs. So there is nothing in the flow logs. Okay, so this is by default. If you see something like this already being created in your account, don't worry. One thing to know is these components are pre-created by AWS, and they are per region, in every region. Okay, so we are going to begin our setup. What we need to do is first we need to set up and create the VPC. So here on the right hand side, just enter create VPC. And here you will see two options, VPC only, and then you can see VPC and more. So when you click VPC and more, you're going to see everything, like you can see the entire, like you can create everything over here along with the preview. So you can even see the preview over here. Okay. So let me give you a gist, or what I will do is I'll say VPC only. So if you create VPC only VPC will be created. And what you will have to do is you will have to create subnets, internet gateway and everything manually. Okay. And if you select this, you get a very nice view over here. You can see over here. Okay. So here we'll go ahead with this approach. Okay. Or alternatively, you can select VPC only and then you can go manually to the other options over here, like subnets, route tables and all of that, and individually create components. But I'll just go by this approach. So here you can see name tag auto generation. So you can enter the value for the name tag. So I'll say project demo over here, something like this. Okay. You can add a hyphen if you wish to. Okay. Then it's asking me for the CIDR block over here. Okay. Now what is CIDR block? So of course, this is going to determine the starting IP and the size of your VPC using the CIDR notation. So if you take a look at the diagram that we have, CIDR notation is 10.0.0.0./16. So that is what is entered over here. If you don't want this, you can modify this accordingly. And you can see a preview over here that you will get approx these many IPs, 65,536 IPs using this CIDR block. Okay. So you have to scroll down now. And here it is asking us no IPv6 CIDR block. So whether it's asking basically whether you want IPv4 or IPv6. So I'm just saying I don't want IPv6. That is something fine. Tenancy. So here we need to select the tenancy. So this dedicated means this you will be assigned dedicated resources by AWS. But if you choose default, you will be given shared resources. So I'm just going ahead with default. Now scroll down. Here you have availability zones over here. So what you can do is you can spread your VPC across two availability zones for high availability over here. You can see this is for high availability. So if I choose 2 over here, you can see AP South 1A is the first availability zone and this is the second availability zone. Okay. And if you choose 2 availability zone, you have to make sure you create either 0 number of public subnets or 2 number of public subnets. So I'll choose 1 availability zone. I'll keep things simple. Okay. And the number of subnets that we want to create, public subnet is 1 and private subnet also 1. If you want 0 or something like that, you can do that. Okay. But here 1 subnet, private subnet is something that we are creating over here. Okay. Now if you come over here, it is auto assigning the CIDR blocks for public and private subnet. But if you want to customize this, you have an option to customize it over here as well. So for public subnet, I can enter the CIDR block as 1 and 20 and not 20, I'll enter 24 over here. Okay. And for private, I'll enter something like, so this can be 2 over here and 24. Okay. So this is public and this is private, and we have 256 IPs being allocated for public and private. And these CIDR blocks I'm getting from here. Okay. So these are 2 defined. I've added these. So 1 public and 1 private is being added. Now, if you scroll down, you also have NAT gateway. Okay. Now, when you create a NAT gateway, be sure that you are being charged for NAT gateway. Okay. There is a charge for NAT gateway, and that is why there is a $sign. So if you want to create one, you can create one. I can say 1 in AZ, and here you will see 1 NAT gateway appear over here. So where is the NAT gateway? Okay. So 1 second. So NAT gateway, and so you can see this one with NAT over here. This is the NAT gateway. Okay. And you can see, so if you hover on this, you will see private. This is project demo. So this is the subnet. Okay. So first this is a VPC. This is 1 subnet which is private, and from private subnet there is the call is going to the route table, and then from route table it will either go to the NAT public like the NAT gateway or the S3. Okay. Now the next option you have, so here you are also seeing an entry for S3. The next option you have for VPC endpoints. Okay. So what you can do is you can enable S3 gateway over here, and this could be used to improve security by accessing S3 directly. Okay, so if you want to do this, you can select this, otherwise you can do none and the entry for S3 will be removed. But it's recommended to have S3 gateway over here. Okay, it can be used for backup and all purposes over here. So you can see over here, VPC enable you to connect to supported services like S3. Okay, there is no additional charge for using gateway endpoints. Okay, but you will be charged for the NAT gateway, but that's okay. So here you have this, and then you can select DNS options over here if you wish to. One more thing I would want to mention about VPC endpoint is that if you this should be enabled generally, it's a good practice. If you want private secure access to AWS services or without going through the internet. Okay, otherwise if you say none, you'll have to go through the internet. So this is for the private subnet and not for public one. So you can see this is being attached only to the private one. Okay, and then you have DNS options. So what does this DNS option do? So it allows instances in the VPC to resolve AWS hostnames and AWS based DNS resolution. So that is something you can do. So for example, when you launch EC2 instances, usually there are IPs, right? So if you click on enable DNS resolutions, the DNS names can be used. For example, EC2 dot something and then .compute.aws amazonaws.com. So they are just like DNS names. You can add like tags over here if you wish to. Okay. Otherwise, you can just preview the information. So you can see the preview over here. We have VPC. Okay, you can say show details over here. And within VPC, you have these two subnets. One is private, one is public. Both are in the same availability zone. Then you have route tables too. One route table is for public, another one is for private. And then you have network connection. So for network connection, this is the internet gateway, which is for the public subnet. And then you have this one NAT gateway for the private subnet. And this is the S3 endpoint, right? That is being enabled here. So the moment I say create VPC, okay, before creating VPC, you can even preview the source code over here. So this is preview code means these are all the commands that will be used. Okay, so if you are making use of something called as AWS CLI, you can get these commands and trigger it from the CLI and the same thing will be created. Okay, so this something can be done. What I'm going to do is I'm going to say create VPC, and the moment you create VPC, you will see, you can see a lot of things being created. Okay, it will take some time for everything to create. So it took few minutes to basically create everything. Okay, there was a wait time when it was creating the NAT gateway and waiting for NAT gateway to activate. Okay, so NAT gateway took some time to activate and then the rest of the resources were created. Now, if you want to see your VPC, you can go over here. Okay, and you can click on your VPCs and you can see VPCs, your subnets. These are two subnets that are created for you. You can see. Okay. And you can go to route tables. These are two route tables that have been created for you. One is for private subnet, other one is for public subnet. You have internet gateways. This is one internet gateway that has been created for you. And then you also have NAT gateway which has been created for you. You can see it over here. Okay. Now, if you are not following this approach, so for example, if you go to create VPC, you have this option of creating VPC and more in one go. If you go with VPC only approach, so of course the creation process is same. It's just that you have to juggle between multiple tabs. For example, you will create VPC over here. Okay. You will enter CIDR, everything. You will enter over here. The same configurations. Then you will come over here. You'll have to define subnets. So you will manually create two subnets over here. So you can like select the VPC over here. For example, this is a VPC. Okay. You can specify the subnet name, the availability zone, in which availability zone you want, the CIDR, and you can also mention details over here and you can say create the subnet. So that is something you can do over here manually. So you'll create two subnets, then you will come to route table. You'll create a route table basically like this. Okay, you have to select VPC and add the route table like so. And then you will have to come to internet gateway. You will create the internet gateway over here like so. Okay, and then you will also create a NAT gateway like so. It's very simple. You have to just select the subnet and connectivity type will be private, and one elastic IP will be allocated over here. Okay, these two things are done. Then what you will have to do is you will have to come over here and go to route table and you will have to add the association over here. So right now, since we created everything together, okay, the associations have been added by default. So you can see over here for private, this is the private route table for the private subnet. So here you can see the association has been added for NAT gateway. Okay, you can see it's been added, and also for public subnet you will see. So this one is public. You will see entry has been added for internet gateway. So you will have to edit routes over here, and you will have to add a new route like so. Okay, so these all things need to be done manually, but I choose to make use of that UI because we were already familiar with the approach, right? So just reiterating, you will go in order over here, right? And the order will be first you will create the VPCs over here, then subnets, then internet gateway you will create, then you create the route table, then NAT gateway, and then basically you will have to come to route tables and you will have to route both the things. So basically you will have to create a route for within the route table of private subnet. You will have to create a route for NAT gateway, and you will have to go to the route table of public subnet and create a route for the internet gateway. That is something you will have to do manually. Okay. Once that is done, you can basically now create resources. So for example, I'll come over here. You can go to EC2 over here. This is EC2. Okay. And just make sure you come over here. You launch an instance. Now when creating an instance over here, whatever you select over here, you enter the name and everything. Okay. If you scroll down, you have an option to select the network, and you can see this is the default network that it has been selected for. So you have to edit over here. You can say not this default network which was already created by AWS. I want to select my own VPC, which is this one, and then you will have to choose the subnet over here. So you have options. So within this VPC you have two subnets. One is the public and the private. Okay, so you can choose your subnet. Do you want to auto assign public IP? So if it's a public subnet, you would want to get a public IP. It's a choice if you wish to. If you select private, okay, this will be disabled. Okay, and then you will create a security group which will define like the inbound and outbound rules for EC2 instance. So all that you will do. So when creating resources over here, EC2 instances, you have an option to select the network settings, and within that network settings, you have the option to choose which subnet and where you want to place this particular instance. Okay, so these instances that have been shown over here, EC2 and all, these can be added. Okay, and once these instances are created, you can add a entry in the route table for the internet gateway like so. Okay, and once you add that, okay, this will be added. Okay, now one thing I would want to tell you over here, okay, you create subnets. So here if you come, you create subnets manually. For example, I'm just giving you an example. Okay, there are a couple of things I want to mention. So you can create a subnet manually. So let's say you create a subnet, okay, and you want that subnet to be public subnet. You give the name for the subnet as public subnet. Okay, let's say I added the name over here, public subnet, availability zone I added, CIDR block I added, and I created it. Now is that subnet public? Just by giving the name over here and setting the CIDR availability zone, is that subnet public? No. The answer is yes, you are creating a public subnet, but that subnet is not yet public. When will it be public? The moment you add a route over here in the route table that connects that subnet to the internet gateway, that is when. So if you come over here, okay, route table, this is for the public. So here you can see the moment you add this over here, okay, that is when this subnet becomes public, because now you are routing all the unknown traffic via internet gateway to that of the internet. So that is when this subnet becomes public. Okay, by default, the subnet is not public. This is something that you should know. Now, once you've created everything, you can keep this and you can take it to your project. Okay, but if you don't have a project and you are just creating for the learning purpose, it's advisable that you delete all the resources from AWS. Okay, because see, VPCs and subnets, you won't be charged for that. It's free. But things like NAT gateways, you will be charged for that. So it's better you delete. And I generally prefer deleting things, okay, after I create. Okay, so you can see all these resources you have created, like VPC, S3 endpoint, subnet, a lot of things has been created. So let us delete everything so that you can also follow. So first I'll go to the NAT gateway. I'll select this NAT gateway and I'll go to actions and I'll say delete the NAT gateway. And it will ask me for the confirmation. So it will ask me to type in delete. So I'll type in delete and oops. So I'll type in delete and then I'll say delete. So it's deleting. It may take a while over here. Now you can go to Elastic IPs over here. So you can see this Elastic IP is being used by our project. So what is Elastic IP? Elastic IP is nothing but a fixed IP that is being allocated. And since we added NAT gateways, it's possible that NAT gateway was using this Elastic IP. Okay, so we'll have to wait until the NAT gateway is deleted. And once it's deleted, we'll have to come over here. We'll have to say actions and I'll have to say release IP address. Okay, so it will tell you, see, it will tell you that it cannot be deleted. Why? Because there is an association with this. Okay, so this is the association ID. It's giving us the ID over here. Okay, if the resources are is associated with NAT gateway, EC2 instance or network interface, please delete those resources first. So that is what we are doing. We are deleting NAT gateway first. So we'll wait for a while until NAT gateway is deleted, and then we'll come and release the Elastic IP. Okay, but until then, what I will do is I'll come over here to route tables. Okay, and let us get rid of the routes. So I'll select these two route tables. I'll say delete the route table. Okay, route tables have associations and cannot be deleted. Okay, so let us go over here and I'll say edit routes. So I'll remove this and I'll say save. Okay, and I'll get this deleted, this route table. Okay, it still has association. Okay, so it is associated to the VPC. You can see over here. So I'll have to probably go to the VPC, select this over here and here. So I should not delete VPC first. I should come to Internet Gateway. We have Internet Gateway that can be easily deleted. So I'll just delete this. So I'll detach this first from the VPC. Okay, I'm not allowed to do so because NAT is still being deleted. Okay, maybe we'll wait for the NAT to be completely deleted. Let me see. Is this being deleted? Yes, it's being deleted. Can we release the Elastic IP? Let me see. Release Elastic IP. Release. Okay, so the Elastic IP is released. You can see. So NAT gateway is now deleted. Okay, this entry will go away. This entry will go away. But I'll come to Internet Gateway. I'll delete this over here. Detach. Okay, so cannot be detached as there are some mapped public. Okay, so this NAT it's still showing over here. Let me refresh. Okay, so it's the moment I refreshed, it checked whether NAT is deleted and now it is allowing me. So I'll say detach over here. I'll say detach Internet Gateway. This is done, and now I can basically go over here. Okay, I'll delete this Internet Gateway. So I'll say delete, something like this. So Internet Gateway is gone over here. Okay, now I'll go to subnet over here and I'll delete these two subnets. So let me delete this, both the subnets. So I'll say delete. Okay, these both are deleted. Subnets gone. Route tables, can we delete route tables now? Okay, what is the problem? Okay, this won't be. So before deleting route table, so let me check over here. So within this, I have some custom routes. So I'll just get rid of those routes. Okay. So I'm just getting rid of those routes. Oops. So I'll go at edit routes. I'll remove this route over here. Okay. This is done. And I'll choose to delete this route table. Okay. So delete this. Okay. This route table was empty, so it got deleted. Does this have anything? No, it does not have anything. So basically all the routes should be removed and then this should be deleted. And that is why it was not allowing us to delete the route table. So route table is gone. Now you come to VPC and if you go over here, let us see the resource map. So you can see there is one route table still there. Okay. It's not showing as deleted over here, but we have actually deleted this. Okay. And this is still there. So I'll just click over here. Okay. And this, okay, it should be deleted now. So let me check over here. I'm on endpoints. Okay, so this is the endpoint over here. So if you scroll down, private link and endpoint, this is the endpoint that was created for S3, right? We had created this. So I'll delete this VPC endpoint as well. Delete. Okay, this is gone. And now if you come over here, okay, how do I refresh over here? There's no refresh button. Okay, maybe I need to do manual refresh. So I'll just do the refresh for entire page. So you can see this is gone, network connections. So this preview or the resource map of VPC is the best way to know which resources exist. So route tables we have deleted, but still here in the preview, you are going to see this entry. Okay. And I realize this entry is of the main route table. Now, if you try deleting this, okay. So if I go over here, let me go over here. Okay. If I try deleting this, let me try deleting this. It won't allow me to delete. Okay. So route tables are main route tables for VPCs and cannot be deleted. So this is one thing that you should be aware of. So every VPC has one main route table. So AWS will always prevent its deletion. Okay. And now the question will be like, how will this be released, right? Because this we have not created. So when you clean up VPC, okay, ignore the main route table. This main route table will be automatically deleted by AWS itself. Okay, so what I will do is, this is our VPC. I'll just come over here. I'll say delete VPC from here, or you can alternatively do it from here as well. You can select the VPC and you can say delete VPC, and you can type in delete over here, something like this. So you can see that VPC is also deleted now. Now everything is cleaned up, okay, and we won't have anything over here. Okay, so this will also get cleaned up. You can see the route table was deleted the moment I refreshed. Okay, so this is about the creation of VPCs and cleanup, and basically there were lots of concepts that we did hands-on, and we saw everything being created on AWS. Now the UI of AWS keeps on changing every now and then, so don't worry if you find few elements here and there. So depending on the video, depending on when you're watching this video, okay, you might see some elements here and there. So AWS keeps on improvising things, but don't worry if you see things here and there. Okay, there won't be any major change. But yeah, building this was fun, and I hope you had fun too.